We've taken a look at our IP configuration before. When we actually set up our IP addresses, we went through our whole variable length subnet masking piece. We really need to take a look at actually putting them on the routers. Again, we'll look at IPv4, look at IPv6, making sure that the routers and or the switches, if we want to be able to manage the switches, they have to have an IP address. We'll make sure that we put something on there so that we can talk to them. So we need to deal with both IPv4 and IPv6. So IP version 4 is the current version that we're using. Again, for an example, 192.168.20.1. We're going to supply a mask, always in dotted decimal notation for IPv4. And this would be our /24, but when you're doing the configuration, you actually have to put it in a dotted decimal. The command in the Cisco world to put an IP address on the interface is once I get to config-if, the command is IP address. What about IPv6? It works very, very similar. The only difference is with IPv6 is what the IP address actually looks like. So an IPv6 address is in the format of 2001.0DB8 colon, let's see, C001 colon FACE colon for a whole group of zeros, and then we'll just, like the router interface might be 1. We have to specify the mask for IPv6 as well, but we'll do that with the slash, and for us it will always be /64, meaning we have 64 bits of host and we have 64 bits of network. The 64 is the same thing as the slash is in IPv4. It's the number of ones in my subnet mask. So in this case I have 64 ones in my mask, and I have 64 zeros as well. And that's that format of my IPv6 interface. How do you suppose we configure it? It would be done the exact same way. So if I look at my config-if prompt, which is the interface that I'm working at with my Scratch, I would do IPv6 address and put the address information in there as well. Again, the whole thing exactly as we see there, 20010DB8 and so forth, goes at the very end, hit enter, and that would accept it. Now, in the Cisco routers, the interfaces are always shut down by default, so we'll always also want to issue the no shutdown command to bring the interface up. And the same thing with v6, no shutdown. If the interface was down, that will physically bring the interface up for me. Again, this is a physical switch. I know it's a command that we put in, but there's no power to the interface unless we issue the no shutdown command, and that will actually bring that interface up. We should perhaps take a look at one of the configurations and how we actually put this onto the router. So let me grab my packet tracer, put my packet tracer back up here for us. So within packet tracer, if I want to do an IPv6 address, we'll take a look at the IPv6 address configuration here. So how do we do it? Well, let's see. Do we have any configuration to start with? So I'll do enable. Actually, let's do a show run first to see what was actually already configured on this machine. So when I look at it, this is R3. R3 actually already has the IPv4 addresses put in place, but we have no IPv6 addresses. So why would we be doing IPv6 on R3? Well, maybe if we look at this whole network segment over here on the right, where switch 0 is, it probably should be switch 3. We can actually change that in the packet tracer environment so we can reference it better. Switch 3. So this whole environment over here is now IPv6. We're migrating over. We were v4, we want to migrate it to v6, so that means we're going to have to put a v6 address here on R3's interface. This is the FA01 interface over here. So what address space are we going to use? Well, let's use, let me see, let me get my pen up here. For this IPv6 interface, we'll use 2001.0DB8 0C001 colon FACE colon, and we'll give the router interface 1, and we'll make our PC the same network, 20010DB8C001 FACE, but we'll make the PC 100, and that I already have configured anyway, but that will give us the ability to go through and ping the v6 address as well if we want to do that. So let's go into our router and actually configure the IPv6 address on the interface. To do that, we'll go into global configuration, which is where we have to start all our configuration. We want to configure the specific interface that's going to be v6, so that would be interface FA01. How do I know that? I built it. So interface FA01, and we need to put an IPv6 address. So the command would be IPv6 address 2001:0db8. And for those of you going, why did you put that leading 0 in there? That doesn't need to be there. It doesn't. We can use the shortcut of not putting any preceding zeros in there. If we do put it in, then most iOSs will actually strip it out and use the easy form for us anyway. We'll do 0db8 :C001:FACE, and then colon. Now I could again here put in another 63 zeros and a 1, but I'm not going to. I'm going to use that ever popular double colon that just fills in to give me 128 bits, and I'll put the 1 after that. I do have to supply my subnet mask /64. I now have that interface up and running. It was running from before because we have an IPv4 address on there. If it didn't, we'd have to issue the no shut command. You can always issue that no shutdown command. It's not going to hurt anything. If it's already up, it's not going to toggle it to off. If I wanted to shut the interface down, I have to issue the shutdown command. If I want to enable it, I need to remove the shutdown command, so that would be no shutdown, and that would bring it up for me. So now it should be working for me. Whoops. So I'll do exit. Exit will come back out of here. How could I see? Well, I can do a show IP. One of the commands we can use to verify configuration, show IP interfaces, and I want to do it in a brief format, so that's brief. That will tell me what interfaces we have configured. Didn't we just do a v6 address? We did, but the command would show IP int brief, which is defaulting to v4. If I want to see the IPv6 interface, it would show, would you believe, show IPv6 interface brief? Exactly, all we're going to substitute. Now, why do I have to do both? Why can't we see both at the same time? When we're working with v6 and v4, the way that we implement it in routers and switches and PCs and Linux boxes, everything, we run it what's called dual stack. So we actually have two separate executables running, one for v4, one for v6. So when we configure everything, we have to configure them separately. When we look at the databases, so if I look at the IP route table, I would do show IP route, that's only version 4, IPv4. If I want to see the IPv6 route table, show IPv6 route. Again, they're completely separate entities, meant really for the whole migration piece, like we're just doing on this interface. This interface already had a v4 address on it. I just added a v6. Once we migrate all the machines on that network segment to v6, we can just remove the v4 address and just talk v6. So again, it's really one of those transition mechanisms that we use to be able to have both v4 and v6 running at the same time. Turn one or the other on or off as we see fit, as we need. So here, show IPv6 int brief. We can see that we actually have fast Ethernet 00, which does not have a v6 address. Internet interface FA01, which is fast Ethernet 01, does have the address we just put on, 2001. Notice that Cisco thankfully removed that leading 0 for me, so just DB8 C001 FACE::1. There is that other address up there, that FE80::260 address. What is that? That's what we call our link local address. And anytime we're using v6, we will always generate a link local address. It's kind of like the APIPA, the Automatic Private IP Address Assignment from v4. Do you remember that 169.254 address space that gets assigned if you don't have a DHCP server? In v6, we did that same type of deal. We have this link local address. And anytime I'm talking to anything that's on my local network, I'm using the FE80 address. And if I leave my network, then I use the 2001 address. If we wanted to verify, let me make sure that I actually put an address on my PC. If I bring my PC back up, a little bit outside the box here, sorry, look at the IP address configuration. And in fact, I did set it to 100. So I should be able to, from my router, go down and ping IPv6 2001:0db8 C001 FACE:100, and we have success. So our IPv6 address is actually working for us as well. Cool, so now we have v4 addresses and we have v6 addresses all sitting on our router. Our v4 and v6 are working. Again, if I do a show IP route, it's going to show me my IP version 4 route. And there's the two directly connected networks. Now, we don't have any routing protocols running, so I don't know the whole infrastructure. We only know what we have directly connected. If I want to see my IPv6 route table, show IPv6 route, and that will show me my IPv6 routing table. Again, we only have one thing configured. We don't have other IPv6 routers in there, so we're not sharing any of that IPv6 information, but we certainly could. Using something like OSPF version 3, we can actually transfer those other v6 addresses if the other routers were configured. As it stands, the routers that we're using don't do v6, so only this right-hand network is the most up-to-date, the most advanced network, and that's where we'll actually be using the IPv6 components. So we looked at configuring our IP interfaces, our fast Ethernet interface, our fast Ethernet 0001 interface, and even our serial interface that we have connected on the other routers. If I go over and look at router 1, router 2 over here, I actually have a serial cable between these two, so I'm running a serial point-to-point link between R1 and R2, and they're fully configured as well. If I go back into R1 and just console as my password, enable would be Cisco, and do a show IP int brief, we can actually see that we have those two interfaces up, fast Ethernet 00 and serial 00 up and running, which are the interfaces we have. Now, if I were managing one of those interfaces, like if I were using an SNMP management application or something just to maintain status that was pinging that 10.1 interface, which is my FA00 interface, or pinging my serial 00 interface, if the interface goes down, then that address is not available anymore. So there may be times, again, our infrastructure doesn't depict multiple paths, but if I had multiple pathing available to me, then let me put this down here and do a quick little draw for you. If for some reason we had another router in here, so I've got my ever popular third router down here providing high availability for me, and I'm going to put another set of serial connections in here. So now this is going to have to be a different network. So this network is not the 10 network, the 20, the 30, the 40, the 50. Maybe this is the 60.0 network. So this is 60.0, so this is 60.1 and 60.2. If I'm managing 20.1, if I'm managing this interface and this interface goes down, it doesn't mean my router's down. What does that mean that I'm managing that interface? I have my SNMP, Simple Network Management Protocol application, or some other vendor's application that's monitoring this router, that's gathering statistics for me. If I'm actually querying the one interface and it goes down, I'm going to think my router's down. I can't get any data from it. But I still actually have an alternate path. I can still get here some other way. Well, again, now if the same thing happens, if my .1 interface goes down and I'm managing the other interface, I still have multiple paths. So how could I make sure that I could always manage this device? Yeah, you could argue, say, well, why don't you manage all 3 IP addresses then? And then if one goes down, you still have the other 2. Well, now I'll have 3 different icons. I've got 3 different management interfaces. I think I would rather have one interface on this router that just never went down. Can we do that? Can we create an interface that never goes down? It is. We can. It's actually called the loopback interface. A loopback interface. A loopback interface. Again, different from the loopback address that we did before. So the loopback interface is a software interface. It's a virtual interface. It's one that we build. Now, we didn't have one in here when we were looking. When I look at my router, and I'll get rid of this extra little picture. No, I'm just going to make it disappear for now. When I look at my router, here's my interfaces. My interfaces are fast Ethernet 00, fast Ethernet 01, serial 00, serial 01. I don't have a virtual interface, but I might want to create one. So that leaves a good question. How do you create it? Cisco makes it very simple. Let me go to my global configuration prompt. And now if I wanted to configure or manage an interface, I would say interface. And then before we did FA01 or FA00. If I want to create a loopback interface, I just say interface loopback 0. That actually created it. Notice the 2 syslog messages that just came up. Interface loopback 0, change state to up. Interface line protocol and interface loopback 0, change state to up. So my physical layer came up, which was the first line, and then my data link layer came up, which was my second line. So that interface is now up and running. I could give it an IP address, but let me do a show IP int brief first. Notice we now have our fast Ethernet 0001 as well as our serial, but we also now have this loopback interface. So this is a software interface. It is always up. It does not have an IP address yet, so I can't manage it. But if I wanted to, I can give it an IP address. IP address 192.168. What did we use for an address space? Did I write it on there? Did we decide what to use? Nope, we didn't decide what to use. So 60 was this other router, so we'll call it 70. How's that? We'll make it 100. We'll do something really cool. We'll make it 100.1. Got to give it a mask. If I put it in here, EXIT, EXIT. Now I do show IP int brief. And sure enough, we have a loopback address. We have a loopback interface and a loopback interface address on there. So as long as I had multiple paths, again, I just drew a router in here, right? I just drew the second router in here. However, now that I have this loopback address configured on my router here, now it doesn't matter which one I'm coming into as long as I have a path. Now, if I'm sitting down here at PC1 and this interface goes down, I do not have a path to my router. That loopback address isn't going to do anything for me. So you also have to make sure that you actually do have a path to the device. But again, managing the loopback interface, if I'm over here someplace on the right-hand side of the screen and I'm managing the loopback, it doesn't matter which one of these two wires. Which two wires? Well, these two wires. If I'm looking here, this wire would be one path, this would be an alternate path. As long as one of these two wires is on, I can manage that loopback interface over here. I would have to have both of these fail, which is a possibility. If router 2 arbitrarily fails, I'm going to lose both of these links, then it wouldn't do me any good. And that's what we use that loopback address for. There's a few other uses for the loopback address down the road, OSPF router ID and so forth. We'll take a look at that when we talk about the routing protocols.